Hello friends, on today's question, a mass m2 placed on the plank of mass m1 lying on a smooth horizontal plane, or horizontal force F alpha naught t, where alpha naught is a constant, is applied to a bar. If acceleration of the plank and bar are a1 and a2 respectively, the coefficient of friction between m1 and m2 is given a mu. Find the acceleration a with respect to time. It means we are going to plot the acceleration of m1 and m2 with respect to time. So it is given that f is alpha naught t, and we have a coefficient of friction between m1 and m2 as mu, and this is smooth. And acceleration of plank and so acceleration of m1 is given as a1, and acceleration of mass m2 placed on the plank is given as a1, and of mass m2 is given as a2. So for start, let's assume that both are moving with same acceleration. Let blocks m1 and m2 move with same acceleration, which is denoted by a. So you can draw, so this is m1 plus m2, and there is a force F which is alpha naught t is acting towards right side, and the acceleration is a in this direction. So we can write the equation of acceleration as a is equal to F upon m1 plus m2, which can be written as alpha naught m1 plus m2 multiplied by t. So what is it? The combined acceleration is a linear function of time t. So you can say from here acceleration a varies linearly with time t. And we also assume let blocks m1 and m2 move together up till t is equal to t naught. So they are moving together up till t is equal to t naught. So from here we can make two cases. Case number 1, for t is less than t naught, so we can say they move with same acceleration, which is nothing but a. So therefore, if a1 and a2 are their respective acceleration, so this will be equal to a. So we can draw the graph partially. This is time and this is the acceleration. So let us mark a point t is equal to t naught. Up till this point they have the same acceleration, that is a1 is equal to a2 is equal to a, and this is the value of a. That is the acceleration. Now for case second, for t greater than t naught, they move with different accelerations. They move with different acceleration. Okay. We can say that acceleration of m1 is a1 and acceleration of m2 is a2. Okay. And moreover, if they are moving with different accelerations, it means slipping between m1 and m2 will start. So the slipping will start. This will result that our Fr, that is the friction. Okay, I forgot to draw the free body diagram. Let me draw it here. So this is our m2 and this is our m1. So a force F alpha naught T is being applied on the block m2. We have a coefficient of friction mu here. So this m2, or rather force F, will try to make sure that m1 travels along with it with the friction force Fr, and respectively there will be a opposite force Fr also acting on m2. So if slipping starts with m1 and m2, Fr will be equal to Fr max, and we can find out here Fr will be equal to, this will be our m2 G, and there will be normal n2. So Fr will be equal to mu into n2, which is equal to mu m2 G. So Fr will be equal to Fr max, and that can be written as mu m2 G. Now the both are traveling with different accelerations. Okay, so we have our m2. It is traveling with the direction acceleration a2. There is a force which is alpha naught T, and in opposite direction there we have a Fr acting on it. And this is our m1. It is traveling with the acceleration of a1, and the force will be acting on Fr. We can say that for block m1, for block m1, Fr will be equal to m1 a1, and Fr is nothing but Fr max. So m1 a1 will be coming equal to as, let me write it here, Fr is equal to mu m2g. So this will be mu m2g. From here we can say our acceleration a1 will be equal to mu m1g divided by m2, and this value is nothing but constant. Okay, because Fr is already equal to Fr max, so the value of the friction now will be constant. So acceleration a1 will be constant, and for m2, for block m2, we can write that our m2 a2 will be equal to F minus Fr, or we can write that a2 will be equal to F minus Fr divided by m2, value of f is alpha naught t divided by m2 minus fr is mu m2 g divided by m2, and finally we get a2 is equal to alpha naught divided by m2 t minus mu g. Okay. This is our equation for a2, and this is the equation for our a1. Let's complete the graph now. Partially we have already drawn it. Around here, this is time t, and this is the acceleration. We've already marked. This is our t is equal to t naught. Till here, they are both traveling with the same acceleration. That is a1 is equal to a2 is equal to a. Okay, and this is our a. After this point, it means for t is greater than t naught, both will be traveling with different acceleration. Okay, and we have our, how can I say it, a1 will be having a constant value. So this will be our a1, and for a2 there will be a change in slope, and it will be a slope as well as because of the, and this will be our a2. So you can say up till t less than t naught, both will be traveling the same acceleration. Let us say that is a, and after that this is for m1 and this is for m2. Okay. Yeah, so this completes the question. Thank you.